All right, the next aspect is electrification. What is electrification? Electrification is the transfer of electron from one body to the other, either by contact or by induction. Electrification is otherwise known as charging. So the aspect that we're going to be considering now is charging. Now, we can consider charging by contact first. Charging by contact. How do we do this? This is the placing of a charged body to be in contact with a neutral body. We place a charged body to be in contact with a neutral body. Let me give you a diagrammatic illustration to this effect. So this is a charged body, whereas the other is an uncharged or a neutral body. You can see they are far apart. This is before charging. This is before charging. During charging, we can have it like this. During charging, we are going to bring both the charged body and the neutral body into contact so that both of them will have a contact with each other. Mind you, the charged body is having 3 positive charges, which will be transferred to the neutral body. This is during charging. So at the end of the day, we can separate both. Initially we had the charged body and the neutral body. So at the end of the day, we'll be having 2 charged bodies. 2 charged bodies like this. After separation, we'll be having 2 charged bodies. This is after charging. Mind you, it's after charging by contact. So initially, the 2 bodies were not in contact with each other. Later, we brought the uncharged body, which is the neutral body, to be in contact with the charged body, and charges from the charged body was transferred to the uncharged body. And later on, they were separated far apart from each other, and the uncharged body has already been charged because charges were transferred from the charged bodies back to the uncharged body. This is how we achieve charging by contact. That is that about that. The next one is charging by friction. Charging by friction. Friction is also another way of contact. So I can say charging by friction can still be under charging by contact. Or we can just decide to take it as number 2, which is charging by what? Friction. Friction has to do with 2 bodies coming to contact, then separating, one sliding over the other. That's friction. Frictional force is the opposing force acting on the surface of 2 bodies in contact, trying to separate them, such that one slides over the other. So that same principle is what we are going to be doing here. Just as if most of us have practicalized this in one way or the other during our secondary school days. I will get a pen. When I get a sheet of paper, we'll cut them into tiny pieces. You rub the pen over your head. When you rub this vigorously on your hair, you realize that when you place it on the piece of paper, this piece of paper will stick to this directly. That is a typical and a common example of charging by friction. So charging by friction has to do with 2 bodies being in contact. We call this the rubbing effect. When you rub one body over the other, there will be charges. One will lose electron, while the other will gain electron in turn. So that is how it works. And basic examples of this is glass rod and silk. Glass rod and silk. Now, we know that electron is being transferred from the glass to the silk. So glass will be losing electron to the silk, while silk will gain the electron. And from what I told you earlier, silk, which is gaining electron, becomes negatively charged. Why? Because it is gaining more electron. Electron is being transferred from glass to silk. But the glass, on the other hand, which is losing electron, becomes positively charged. So silk is negatively charged, while glass is positively charged. Why? Silk is gaining electron that was lost from the glass. It is accepting the electron. It is gaining more electron, so silk becomes negatively charged. Whereas the glass that is giving off, that is losing electron, becomes positively charged. That is in the case of glass and silk. When you rub the glass over the silk material. Another typical example is that of ebonite rod and fur. Ebonite rod. When you rub ebonite rod across fur, electrons will be transferred from the fur to the ebonite rod, such that the fur will be losing electron. And as such, as fur is losing electron to the ebonite rod, fur becomes positively charged. Why? Because it is the fur that is losing electron to the ebonite rod. So it's positively charged, whereas the ebonite rod, which is gaining electron, becomes negatively charged. Take note of that. We can have another example. Glass rod rubbed across fur. The same thing that happens to ebonite rod will happen in the case of glass rod rubbed against fur. The fur will transfer electron to the glass rod, making the fur positively charged, whereas the glass rod will become negatively charged. So that's that about that for charging by friction. The two materials will be in contact, and not just contact. One will have to be rubbed across the other. Hope you understand. Such that both of them will be charged. One of them will lose charge, while the other will gain charge. But both of them will be charged anyways. One will be negatively charged, the other will be positively charged. That's about charging by friction, which is rubbing. You rub one over the other. The next one, charging by induction. Charging by induction. Charging by induction involves charging a neutral body by placing a charged body near it without any contact between the two of them. We are charging a neutral body by placing a charged body just close to it, near it, but there is no contact whatsoever between both of them. What I am saying here is this. Yeah, this is an illustration of charging by induction. Let me just give you a brief explanation. You see, this C here is a conductor that is placed on an insulated stand, having both the positive and negative charges here. Then we also have a negatively charged body B here, which is brought closer to this conductor of the positive and negative charges, as you can see. Body B is not actually touching body C. That's by induction. It's just brought closer to this, which will now result to free electrons from body C being repelled away from B. Free electron from here is being repelled from this. So by the time we introduce an act, we introduce the act, or we touch using the finger, we realize that electrons will now flow through the heart or flow through the finger and enters the heart, such that when we now move this one back a bit, we realize that there will be an electron deficit in the conductor C here, so that all the negative electrons would have entered the heart like this. So at the end of the day, we'll be having only the positive electrons here. So this has been charged by what? Induction. In recent, we did not bring body B in contact with body C. We only brought it closer. Then we introduced an heart, which evacuated all the charges, the negative charge of body B into the heart, leaving only the positive charge in the conductor body C. Now, we are going to be talking about some basic instruments used in this study. The first one is what we call the electroscope. Electroscope. What is electroscope used for? Electroscope is an instrument used to detect or test small electric charges. The instrument used to detect or test small electric charges. That is electroscope. What about another one we call electrophorus? Electrophorus. Electrophorus is a device for transferring or storing electric charges. While electroscope is used to detect or test electric charges or small charges, electrophorus will either transfer or store the charge. So that's that about that. And that takes us to the next aspect, which is gold leaf electroscope. Like we already know, electroscope is used to detect or test small electric charges. One of the known electroscope is what we call the gold leaf electroscope. What does it do? It detects the existence, nature, and magnitude of electric charges. It detects the what? Existence, nature, and magnitude of electric charges. Talking about the existence, to let us know if charges are present or not. Is there a charge? Yes or no? It detects the existence. Nature of the charge. Is it a positively charged particle body or a negatively charged body? The magnitude. How much, how large is the charge? It tells us. So it will be doing three things to help us detect the existence, the nature, and the magnitude of electric charges. Now, let us go straight to describing gold leaf electroscope. How do we describe gold leaf electroscope? Gold leaf electroscope consists of a metal cap connected to a metal rod. Consists of a metal cap metal cap connected to a metal rod and a gold foil. Mind you, the gold foil is otherwise known as gold leaf. A metal cap connected to a metal rod and a gold foil, which is housed in an earthen metal case, which is housed in an earthen metal case with a viewing glass window. So the it becomes very transparent in such a way that we can see either the convergence or divergence of this gold foil at the end of the day when a charged body is brought closer to the metal cap. So that's what we are saying. We do it in such a way that we now have insulator covering this part, joining them together like this. This is the insulator. That insulator, we call it perspex. Perspex. So this is the insulator here. This part is the what? earthened metal case. So if they ask you to describe a gold leaf, this is a gold leaf electroscope. Gold leaf electroscope. It consists of a metal cap connected to a metal rod and a gold foil and housed in an earthen metal case with a glass viewing window. And all the connection is stopped by an insulator called perspex. So that's just description, both the verbal and the diagrammatic description of gold leaf electroscope. Most of the time, we charge the electroscope, the gold leaf electroscope, by induction, just by bringing a charged body closer to the metal cap. We get the electroscope charge. And I'll be giving you a table that best explains everything so that you will not need to cram anything. Then afterwards, I'll solve like 2 questions for you to understand everything perfectly. So I will use this table to explain the effect of the leaf, that is the gold leaf, in the gold leaf electroscope. Eye to a move when a body is being brought closer to the electroscope. A charged body, of course. So if the charged body is positively charged and the electroscope is positively charged as well, the effect on the leaf will be divergence. This is what I am saying. This is the metal rod. This is the gold leaf. If the gold leaf is moving closer like this, it converges. But if it is moving far away like this, it diverges. I believe you understand. When it comes closer like this, it converges. When it goes this way, it diverges. So that's it. So when we have a positively charged body being brought closer to a positively charged electroscope, the effect of that gold leaf will be divergence. So that's about that. So when we have a positively charged body being brought closer to a negatively charged electroscope, the effect on the leaf will be convergence. In the same way, we have a negatively charged body being brought closer to a positively charged electroscope. The effect on the leaf will also be what? Convergence. Now, if we have a negatively charged body brought closer to a negatively charged electroscope, the effect on the leaf will be divergence. Now, when we have uncharged body brought closer to a positively charged electroscope, the effect on the leaf will be convergence. In the same way, when we bring an uncharged body closer to a negatively charged electroscope, the effect on the leaf will also be convergence. So that's that about that. I want us to use this concept to solve 2 UTME questions. Let's consider the first question, which is taken from 2014 UTME question. They said, when a negatively charged rod is brought near the cap of a charged gold leaf electroscope, which has a positive charge, the leaf will what? What will be the effect on the leaf? Please follow through. This particular table answers both questions. The first one is when a negatively charged rod, so the rod is the body, negatively charged rod, brought near to the cap of what kind of a charge is the gold leaf having? It's having a positive charge. So negatively charged rod to a positively charged electroscope. Let's look for it. Negatively charged rod body to positively charged electroscope. So what will happen? Convergence. 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 What convergence means here is collapse. Diverge is divergence. Collapse means convergence. And when they say reduce, it means convergence. Collapse means convergence. Increase means divergence. Diverge means divergence. I believe you understand that. So in this case, they said when a negatively charged rod is brought near the cap of a charged good leaf electroscope, which has a positive charge, the leaf will what? Collapse. The leaf collapses. So option A is what? Correct for this. Then question 2 says, as a positive charge rod is brought nearer to the top cap of a positively charged gold leaf electroscope, the divergence of the leaf will, take note, the body is positively charged. Likewise, the what? Gold leaf. So we have positive, positive. Positively charged body, positively charged gold leaf electroscope. What happened? There is divergence. So the divergence will what? Increase. Steadily increase, which is option B. That's correct. So that's that about that. We move to the next aspect, which is Coulomb's law.